The denominator, and so this will look at examples where you might have a radical in the denominator. So rationalizing the denominator is important when you look at examples like 3 over the square root of 14, for example. Okay, if you have an example like this, remember one of the rules were that you can't have a radical in the denominator, so we want to try to get rid of this. So here are the steps for rationalizing the denominator. First, we're going to multiply the numerator and denominator by the radical in the denominator. Okay, so for example, I have 3 over the square root of 14. I want to eliminate the fact that there's a radical of 14 underneath the denominator, or in the denominator. And so what I'm going to do is I'm going to multiply the numerator and denominator by the square root of 14. Okay, so multiply the numerator by the square root of 14 and multiply the denominator by the square root of 14. And what will end up happening here is the radical in the denominator will be eliminated once I do this. So I end up with something like 3 times the square root of 14 over the square root of 14 times the square root of 14. Now I'm going to show you what happens on the side here. When you multiply the square root of 14 times the square root of 14, you get the square root of 196. And coincidentally, that's equal to 14. And so when you multiply a radical by itself, it's essentially the same thing as squaring that number. And the square, when you square root a number and then you square it right after, you end up getting the radicand value that's underneath. Okay, so that's a quick way of eliminating a radical from the denominator. So I know that when I have the square root of 14 times the square root of 14, that simplifies to just 14. Okay, and then from here, if you can simplify it further, so for example, if I can reduce 3 in the numerator with 14 in the denominator, then I would continue to do that. But if you can't reduce it, then you leave it the way it is. Okay, so let's look at some examples. So in example 3, we're just simplifying, and so you can see in the first example that I have a radical in the denominator, and a radical is not in simplified form unless there are no radicals in the denominator. And so what I'll do is multiply the numerator and denominator by the square root of 7. And so in the numerator I get 2 times the square root of 7, and in the denominator the square root of 7 times the square root of 7 is going to just give me 7. Or if you think about it as multiplying radicals, that would give me the square root of 49. And the square root of 49 I know is equal to 7. Okay? And again, in this case, I can't simplify this. Remember that you can only simplify radicals with radicals and number terms with number terms. So for example, I can't say, oh, 7 in the radical here can reduce with the 7 in the denominator here. That's not possible. Okay? You can try to reduce 2 and 7, but in this case, that's not possible either. Okay, let's look at the last example. I want to try to eliminate the square root of 11. I don't need to eliminate the 2 here because the 2 is fine. I'm okay with having a number in the denominator as long as it's not a radical. So what I end up with is 3 times the square root of 11 divided by 2 times the square root of 11 times the square root of 11. Now I can combine these two because they're both radical parts. Okay? This is all multiplication, so be careful. You're not going to do 2 times root 11 and then root 11 times root 11. You're only multiplying all of these terms together. So combine the radicals. Okay? So the square root of 11 times the square root of 11 gives me 11. And so 2 times 11 is 22. Okay, so I get 3 root 11 times 22, divided by 22. And again, if you can simplify the 3 and the 22, then you would continue to do so. But in this case, I can't, so I'm going to leave it the way it is. Okay, products and quotients of radicals. So we're going to look at the steps for the product and quotient of radicals. Product just means you are multiplying. Quotient just means you are dividing. So to multiply or divide radicals, what you're going to do is multiply or divide the coefficients and then multiply or divide the radicands. So for example, if you have 3 times the square root of 5 multiplied with 4 times the square root of 15, what you're going to do is you'll notice that there's a coefficient part. We're going to multiply the coefficient part, and then you'll notice that there's a radicand part, so we're going to multiply the radicand part. Okay, so for example, I would do 3 times 4, which is equal to 12, and then the square root of 5 times the square root of 15, which is equal to the square root of 75, once I multiply the radicand parts together. So 5 times 15 gave me 75 under the radical sign, and 3 times 4 gave me 12 outside of the radical sign. And then what I'm going to do is simplify. So the next step is to simplify. And I know I can simplify the square root of 75. And that would give me 12 times the square root of 25 times the square root of 3. So I broke down 75 into 25 and 3. And then I know the square root of 25 is equal to 12. And this is all multiplication. And so I get 12 times 5, which is 60. And then I have 60 times the square root of 3. Okay, so just some more notes about some of the properties of radicals. If you have x times the square root of a times y times the square root of b, you can multiply x times y because they are the coefficients. And then you can multiply the square root of a times the square root of b since those are your radical parts. Okay, same thing with division. And what you'll notice again is that you can work both ways. So you can break it down or you can combine them. The other thing you'll notice is that the restrictions on the values of a and b are similar to what you saw earlier. The restrictions are that a and b have to be greater than or equal to 0 when you're multiplying. And again, that's because you can't find the square root of a negative number. Whereas when you are dividing, you know that the only restriction that's changed is that b has to be only greater than 0, so b can only be positive numbers. It cannot be equal to 0 because the square root of 0 would give you 0, and so you would end up having division by 0, which is undefined. Okay, so that's the reason why you can't have b equal to 0. Okay, let's look at some examples. And so in these examples, we are just simplifying. So we have 3 times the square root of 5 times negative 2 times the square root of 7. And we have 3 times negative 2. So we're going to multiply the coefficient parts and then multiply the radicand parts, just like we talked about earlier. And so 3 times negative 2 gives me negative 6. And now I'll look at the radicand part. And then I have square root of 5 times the square root of 7. So 5 times 7 is 35. And that goes underneath the radical part. And again, if you can simplify this, and you would continue to simplify it further. And I know that 35 has no perfect square factors. So that's as far as we can go with the first question. Okay, the second question looks at some division between two radicals. And so I have 12 times the square root of 10 divided by 4 multiplied with the square root of 2. And so I can rewrite this in a different form. So this is division across. I'm going to rewrite it as division down because sometimes it just makes it easier to see what the operations are and what values I can simplify with other ones. And so here I can see that I can reduce the 12 and the 4. And 12 divided by 4 gives me 3. And again, same idea here. I have the square root of 10 divided by the square root of 2. And I know that can simplify to the square root of 5. Since it's division, I did 10 divided by 2, and 10 divided by 2 gives me 5. And again, I can't reduce the square root of 5 any further, so I know that that's as simplified as it's going to get.